some extra problems of derivatives. See the question here. Differentiate log of log x to the base 7. So far we have differentiated the function. It's of the form log of log x, right? Here this means here nothing was given and the base of this function was e. So directly we can differentiate log of log x. But here you can see this one, that base of this log of log x is 7. So directly we cannot differentiate this one. First what you have to do, consider the given function as y. This is very important, right? Without considering we cannot differentiate this. First we consider log of log x to the base 7. Right? Now by using the properties of a logarithm, by using the change of base, log a to the base b. Right? Log a to the base b can be written as log a to the base e by log b to the base e. We can write like this by using that property. This one can be written as log of log x. Right? Here nothing is there. I mean that means the base will be e divided by log 7. Is it clear? Now y is equal to this one. Now we can differentiate the function. We will differentiate the function with respect to x. Differentiate the function with respect to x. So derivative of y with respect to x will be now dy by dx. This is equal to now 1 by log 7 will be constant. We will take as it is 1 by log 7. Now derivative of log x will be log x. Derivative of log x is 1 by x. So this will be now 1 by log x. Then derivative of log x will be 1 by x. Is it clear? Finally we arrange this one. This is x into log x into log 7. So this is the derivative of a given function. So the next question, differentiate cos inverse of sin x. First one, you have to consider this as 1, right? Y is equal to cos inverse of sin x. Here to differentiate this function, either you can go with the cos inverse x formula or else you can convert the sin x into the cos formula. So if you convert sin into the cos so that we can cancel cos inverse and cos, then you can differentiate. We will see both the methods. Here what we can do, this is equal to cos inverse of sin x can be written as cos of pi by 2 minus x. Right? Agree? Cos of pi by 2 minus x. Because cos of pi by 2 minus, it will be in the first quadrant. So pi by 2 is there, so cos changes to sin. So here cos inverse and cos will get cancelled. This is now pi by 2 minus x. We got y is equal to pi by 2 minus x. Now we differentiate this one with respect to x. Differentiate the function with respect to x. As I told you, don't forget to write this part. Okay. The derivative of y will be now dy by dx is equal to derivative of pi by 2 is constant, so it is 0 minus derivative of x will be 1. So dy by dx is equal to minus 1. If you use the formula, so y is equal to, the question is y is equal to cos inverse of sin x, right? So now differentiate, this will be now dy by dx, which of the form cos inverse of x. What is cos inverse of x? Minus 1 by root of 1 minus x square. So minus 1 divided by root of 1 minus x square. X is now sin. So this is now sin square x. And derivative of sin x. What is it? Yes, we have done with this cos inverse. So we have to differentiate sin x. So derivative of sin x will be cos x. So this is equal to minus 1 by root of 1 minus sin square x. By using a fundamental relation, this one can be written as cos square x, right? So square and square will get cancelled. This will be now cos x and multiplied with cos x. So that I can cancel this cos x and cos x. So this is equal to minus 1. So derivative of this dy by dx is equal to minus 1. I hope you understood this one. Differentiate tan inverse of sin x divided by 1 plus cos x. First one, you have to consider this as 1, right? Now, if you apply the tan inverse of x formula, it will be very lengthy because here two functions are there. Sin x is there, again 1 plus cos x is there, right? So directly we cannot differentiate this. We will substitute the formula. I mean, we will convert this term into the tan. So if you convert this one into the tan, then tan inverse and tan can be cancelled. Then easily we can differentiate. So what we can do is, here we will write this as tan inverse of, what is sin x? By using the sin 2x formula, sin 2x will be 2 sin x into cos x. So sin x will be 2 sin, right, x by 2 into cos x by 2. Is it clear? 2 sin x by 2 into cos x by 2. 1 plus cos x. What is 1 plus cos x? It will be 2 cos square by 2. Is it clear? 2 cos square x by 2. One more thing you have to remember. Here the value of cos x can't be equal to minus 1. If it is cos x is equal to minus 1, then it will be in the not defined form. So cos x can't be equal to minus 1. I mean that x is not equal to the odd multiple of pi. I mean x is not equal to pi or 3 pi or 5. Remember this odd x cannot be equal to the odd multiple of pi. Now we'll continue this one. So here cos square x by 2 and cos x by 2 will get cancelled. So this is equal to tan inverse of 2 and 2 will get cancelled. Sin x by 2 by cos x by 2 will be tan x by 2, right? So here tan inverse and tan will get cancelled. So this is equal to x by 2. So far we have not differentiated the function. Now we have to differentiate the function with respect to x. Okay, differentiate the function with respect to x. Derivative of y with respect to x will be dy by dx is equal to 1 by 2 is constant and derivative of x with respect to x will be 1. So dy by dx is equal to 1 by 2. So the next one, differentiate sin inverse of 2 to the power x plus 1 divided by 1 plus 4 to the power x. Directly we cannot differentiate this one. So you have to give the substitution for this. To give the substitution, first we will check the value of this one. Here you know that sin inverse function, the domain is defined between minus 1 to 1. So this value should be between minus 1 to 1, right? So that is 2 to the power x plus 1 divided by 1 plus 4 to the power x should be between minus 1 to 1. That is minus 1 less than or equal to this, less than or equal to 1. You know that sin inverse of minus x will be minus sin inverse x, right? So we will consider this one as a positive quantity. So this is, we will consider the modulus. So this is now 2 to the power x plus 1 divided by 1 plus 4 to the power x is less than or equal to 1. Is it clear? So this is less than or equal to 1. By this I can write 2 to the power x plus 1 is less than or equal to 1 plus 4 to the power x. Now we will write this one as 2 to the power x into 2, right? Less than or equal to 1 plus 4 to the power x can be written as 2 square whole to the power x, or we can write 2 to the power 2x. Is it clear? 4 square to the power x, so it will be 2 to the power 2x. So now we will divide by 2 to the power x. If I divide by 2 to the power x, this will be 2 less than or equal to 1 by 2 to the power x plus 2 to the power 2x divided by 2 to the power x. It will be 2 to the power 2x minus x. So it is 2 to the power x. Is it clear? By this we got the value of 1 by 2 to the power x plus 2 to the power x is, right? This is greater than or equal to 2. So this value is greater than or equal to 2. I mean this is satisfied. I mean 2 to the power x and divided by 1 plus 1 divided by 2 to the power x is satisfying for all the real numbers. Since this is satisfying for all the real numbers, we can give the substitution as 2 to the power x is equal to tan x. Is it clear? The value of this one 2 to the power x is satisfying for all the real numbers. We can give this as 2 to the power x is equal to tan x, and we'll substitute this. Y is equal to sin inverse of 2 to the power x plus 1. I can write this as 2 to the power x into 2 divided by, right? So this is 1 plus 4 to the power x. We can write as 2 to the power x whole square. Is it clear? 2 to the power x plus 1 is 2 to the power x into 2. 1 plus 4 to the power x is 2 to the power x whole square. And we'll substitute this sin inverse of, so this is now 2 to the power x is now tan x into 2, right? Divided by 1 plus 2 to the power x is tan x. So this will be now tan square x. So it's of the form 2 tan x divided by 1 plus tan square x. Which formula? It is sin 2x, right? So this is equal to sin inverse of sin 2x. Is it clear? Sin 2x, so sin inverse and sin will get cancelled. So this is equal to 2x. We got the value y is equal to 2x. Now we differentiate this function with respect to x. Differentiate with respect to x. Okay. Y is equal to 2x. One more thing. Before differentiating this one, we had given the substitution, right? 2 to the power x is equal to tan x. So what is the value of x? X will be equal to tan inverse of 2x. Is it clear? Tan inverse of 2 to the power x. Here y is equal to 2x. Directly we cannot differentiate because we have given the substitution here. That is 2 to the power x is equal to tan x. By this x is equal to tan inverse of 2x. Before differentiating this one, we will substitute the value. Y is equal to 2 into, what is the value of x? Tan inverse of 2 to the power x into 2. 2 is as it is. So now we will differentiate the function with respect to x. Differentiate the function with respect to x. Remember this, okay? If you are given the substitution, then you have to substitute. Then only we can differentiate. Directly we cannot differentiate here. So derivative of y with respect to x will be dy by dx is equal to 2 is constant as it is. Tan inverse of 2 to the power x. What is the derivative of tan inverse x? It is 1 by 1 plus x square. That is 1 divided by 1 plus x square. In the place of x, we have 2 to the power x. So this is now 2 to the power x whole square. Is clear? We have done this tan inverse. Now we have to differentiate 2 to the power x. 2 to the power x will be derivatives of the form a to the power x, right? Derivative of a to the power x will be a to the power x into log x. 2 to the power x into log 2, and this 2 we have written already, right? So this is equal. Now we can simplify 2 to the power x and 2 to the power 1. So it will be 2 to the power x plus 1 divided by 1 plus, this is now 2 square will be written as 4 to the power x into log 2. So clear? The derivative of this function dy by dx is equal to the power x plus 1 divided by 1 plus 4 to the power x into log 2. I hope you understood this one. So the next problem. Differentiate sin square x with respect to e to the power cos x. I mean how to differentiate this function. Sin square x with respect to the e to the power cos x. Directly we cannot differentiate this one. We will take this one as one variable. You can observe here both are in the form of x, right? Here the variable are x, so we will consider this as some other than x. Don't consider as other than x. We can consider this. We will consider as y is equal to, is it clear? Y is equal to sin square x, and the variable we will consider as t. T is equal to e to the power cos x. Is it clear? First, for the given function we have considered y is equal to sin square x and t is equal to e to the power cos x. Now we are differentiating sin square x e to the power cos x. I mean we are differentiating y with respect to t. Is it clear? We are differentiating the sin square by x means what? You are differentiating y with respect to t. That means you have to find dy by dt. I hope you understood this one. Differentiating the function y with respect to t will be dy by dt. Now here both are in the variables x, so we will differentiate this function with respect to x. So differentiate the function with respect to x. So derivative of x. We are differentiating the function with respect to x. Derivative of y with respect to x will be now dy by dx, right? So this is equal to sin square. It's of the form 2 sin x square. X square will be 2 sin x and derivative of sin x will be cos x. We got dy by dx. Now we differentiate this one with respect to x. So derivative of dt will be with respect to x is dt by dx. So this is equal to e to the power cos x. What is the derivative of e to the power x? Same it is e to the power cos x. Now we have to differentiate cos x. Derivative of cos x will be minus sin x. So clear? But we need to find dy by dt. So dy by dt can written as dy by dx whole divided by dt by dx. It's in the parametric form, right? Two functions are given. So dy by dx will be 2 sin x into cos x, 2 sin x into cos x whole divided by minus e to the power cos x into minus sin x. But this will get cancelled. So this is equal to minus 2 cos x whole divided by e to the power cos x. So derivative of the function sin square x with respect to e to the power cos x will be minus 2 cos x divided by e to the power cos x. So the next problem, it is based on the continuity. Find the value of x so that the function f of x is continuous at x is equal to 0, where f of x is equal to 1 minus cos 4x divided by 8x square if the value of x is not equal to 0, and constant k if the value of x is equal to 0. What is given? The function is continuous at x is equal to 0. First we have to write, since the function is continuous at x is equal to 0, right? The function is continuous at x is equal to 0. We can write limit of x tends to 0, f of x should be equal to f of 0, since the function is continuous at x is equal to 0. Now we'll substitute the function limit x tends to 0. equal to, when the value of x is equal to 0, the value of x will be constant, so it is f of 0 is equal to k. Right? Now we need to find the value of k. Now 1 minus cos 4x is there. You know the formula, 1 minus cos 2x. By using the cos 2x formula, we can write this as 2 sin square x. Now here we have 1 minus cos 4x, so we need to multiply the angle by 2. If I multiply angle by 2, 1 minus cos 2 of 2x is equal to 2 sin square 2x. Is it clear? We multiply the angle by 2. So 1 minus cos 4x can be written as limit of x is tending to 0. So this will be now 2 sin square 2x divided by 8x square is equal to k. Now here I can cancel this and this will be 4. Right? Again further we can write this one as limit of x tends to 0. Here sin square 2x is there and 4x square is there. So we can write this as sin 2x divided by 2x whole square. Can we write like this? This is equal to k. This will be sin square 2x and 2 square will be 4x square. So we can write like this, right? So now limit of x tends to 0 sin 2x by 2x whole square. By using the Sandwich theorem, this one we can write as 1, right? So value of this is equal to 1. So the value of k is equal to 1. I hope you understood this one. Since why? Limit of x tends to 0, sin x by x is always equal to 1. In the place of x, here we have 2x whole square will be equal to 1. Next question, simple it is. Let f of x is equal to x mod x and discuss the continuity at x is equal to 0. We need to discuss the continuity. So first we will define the function at x is equal to 0. So the function f of x we can define as, it is, see here, x into mod x will be minus x if the value of x is less than 0. Right? Suppose the value of x is less than 0, then mod x will be minus x. So this will be minus x square. If the value of x is greater than or equal to 0, so this will be now x into and mod x will be positive, that is x. So we can define this function as, this is minus x square if the value of x is less than 0 and this will be x square if the value of x is greater than or equal to 0. Now simple it is, let's check the continuity at the x is equal to 0. I mean you have checked the left hand limit as well as right hand limit. Limit of x is tending to 0 minus f of x is equal to limit of x is tending to 0 minus, I mean the value of x is less than 0, so it will be minus x square. So if you substitute the value of x as 0, so this is equal to 0. So left hand limit will be equal to 0 and similarly right hand limit also will be equal to 0. Right? Limit of x tends to 0 plus f of x. So this is equal to limit of x is tending to 0 plus the value of x is greater than 0, the function will be x square. So this is also equal to, if you substitute 0. So left hand limit is equal to the right hand limit and f of 0 is also equal to 0. So the function is continuous at the point x is equal to 0. See this problem, find dy by dx. Y is equal to tan inverse of 3x minus x cube divided by 1 minus 3x square. Right? See, directly we cannot differentiate this function. So we need to give the substitution. Similar problem we have solved in the inverse trigonometry. Not only similar, same problem was there. Right? We had given the substitution and there one more thing, the range of the x was defined. But here the range of x is not defined. We will define the range of the x. What is the value of x is between? I mean where to where it is. Is it clear? Now what substitution we have to give? To simplify this one, we know that it is equal to x is equal to tan theta. Is it clear? If I give that substitution x as tan theta, so this will be now y is equal to tan inverse of 3 x is tan theta minus x cube will be tan cube theta divided by 1 minus 3 tan square theta. Now this is the formula for 3 tan 3 theta, right? So directly we can write this as tan inverse of tan 3 theta. Is it clear? Tan inverse of tan 3 theta. Here you have to observe this one, tan 3 theta is there. The value of 3 theta should belong to the restricted domain of a tan function. It is minus pi by 2 to pi by 2. Is it clear? Restricted domain of the tan function, 3 theta belongs to minus pi by 2 to pi by 2. That means theta is belongs to, if I divide by 3, so this will be minus pi by 6 to pi by 6. Is it it clear? Now what is the value of theta? X is equal to tan theta. So theta will be equal to tan inverse x. So now by this we can write tan inverse x is belongs to minus pi by 6 to pi by 6. So this means the value of x belongs to tan of, is it clear? Minus pi by 6 to tan of pi by 6. What is tan of minus pi by 6? It is minus 1 by root 3. So this is minus 1 by root 3 and the value of tan pi by 6 will be 1 by root 3. So by this we can say that the value of x is between minus 1 by root 3 to 1 by minus 1 by root 3 less than x less than 1 by root 3. That is the range of the x function. Is it clear? Now this is equal to 3 into theta. Tan inverse and tan will be cancelled. So 3 into what is theta? It will be tan inverse x. So this is equal to 3. What is the derivative of tan inverse x? 1 by 1 plus x is 2. So derivative, here derivative of y with respect to x will be, this is compulsory, dy by dx is equal to 3 by 1 plus x is 2. So this is the derivative of a given function. The next one, find dy by dx sin inverse of 2x into root of 1 minus x square. First we have to consider this as 1, right? Directly here also we cannot differentiate. What we have to do? Give this substitution. We will give the substitution x is equal to sin theta. Is it clear? The value of x is equal to sin theta. So this will be now y is equal to sin inverse of 2x is sin theta into root of 1 minus sin square theta will be cos square theta. Square and square will get cancelled. This will be now cos theta. We have solved this problem in the inverse also. So this will be now sin inverse of sin 2 theta. Is it clear? Sin 2 theta. So this is equal to 2 theta. Y is equal to 2 theta. Now we will substitute the value of theta. So y is equal to 2 into theta is sin inverse of x. So dy by we differentiate this function with respect to x. So derivative of y with respect to x will be dy by dx. So this is equal to 2 into 1 by root of 1 minus x is 2. So this is the derivative of a given function. Can you say what is the value of x? The range of x? Here sin 2 theta is there, right? So the value of 2 theta should belong to the domain, that is minus pi by 2 to pi by 2 restricted domain, right? So this will be now theta belongs to minus pi by 4 to pi by 4. Now what is the value of theta? We have substituted x is equal to sin theta. Theta will be sin inverse x, right? So this is now sin inverse x is belongs to minus pi by 4 to pi by 4. So the value of x is belongs to sin of minus pi by 4, right? Sin of minus pi by 4, comma sin pi by 4. Is it clear? So the value of x is between sin of minus pi by 4 will be minus 1 by root 2 and sin pi by 4 will be 1 by root 2. Is it clear? The value of x, that is x is between minus 1 by root 2 less than or equal to x less than or equal to 1 by root 2. No need to solve this one, okay? This is enough. Just to understand that, explain that one, x is belongs to minus 1 by root 2 to 1 by root 2. I hope you understood this one. So the next problem, y is equal to sin inverse of x into root of 1 minus x minus root x into root of 1 minus x square, and the value of x is between 0 to 1. You have to find dy by dx. Directly you cannot differentiate this one. For that, we will give the substitution for x and root x. What we do is, just we do the substitution x is equal to sin a, okay, and root x is equal to sin b. So clear? Since the value of x is between 0 to 1, root x is also between, root if you consider also this is between, root x is also between 0 to 1. Now we will substitute this one. So I can write y is equal to sin inverse of x, we are given the substitution as sin a, okay, into root of 1 minus, see at the value of x I can substitute either sin b or I can substitute x is equal to sin square b, right? We can substitute x is equal to sin square b. So we will substitute here x is equal to sin square b minus, what is root x? It is sin b into root of 1 minus x square. X square here we will substitute it as a sin square a. Sin square a. Is it clear? To get the formula we are doing this one. Root of 1 minus sin square a. So this is equal to sin inverse of sin a. What is root of 1 minus sin square a? It will be cos minus sin b into root of 1 minus sin square will be cos a. Now it's of the form, you can see sin a cos b minus sin b cos b. So we can write this as sin inverse of sin of a minus b, right? Sin of x minus y formula. You know this, in the form place of x and y, here we have a and b. So this is equal to a minus b. So y is equal to a minus b, but we need to substitute that the value of y is equal to, what is a? A is sin inverse of x minus b is sin inverse of root x. Is it clear? Now we differentiate this function with respect to x. Differentiate with respect to x. So derivative of y with respect to x will be dy by dx is equal to sin inverse x is 1 by root of 1 minus x square minus sin inverse of root x. In the place of x here we have root x, so this is minus 1 by root of 1 minus root x whole square. It will be x. Then you have to differentiate root x. Derivative of root x will be 1 by 2 root x. I hope you understood this one. So this is the derivative of a given function. Root 1 minus x square divided by x with respect to cos inverse of 2x into root of 1 minus x square, and the value of x is between 1 by root 2 to 1. This type of problems are not important for theory, okay, only for the objectives. See this one, directly we cannot differentiate this. For that, first you have to consider the function. Let me consider y is equal to, okay, tan inverse of, because we are differentiating this function with respect to that. So tan inverse of root of 1 minus x square divided by x, and we consider that as t is equal to cos inverse of 2x into root of 1 minus x square, right? Directly we cannot differentiate this one. For that, first we need to give the substitution. Let me consider the substitution x is equal to sin theta. Similar problems we have solved in the inverse trigonometry. There I have not explained why we have to give the substitution x as sin theta, because it is not necessary, but you should know that why we can give this as sin theta, because the value of x is between, see there, 1 by root 2 less than x less than 1. So if I give x as sin theta, so this will be 1 by root 2 less than sin theta less than 1. So the value of theta is between sin inverse of 1 by root 2 will be pi by 4. So this is less than pi by 2. So the value of theta is between pi by 4 to pi by 2. So the function is defined for sine function, right? Sine domain will be, the restricted domain is between minus pi by 2 to pi by 2. So here pi by 4 to pi by 2 is there. So it is belongs to this only. So we can give the substitution as x is equal to sin theta. Now we will consider this, y is equal to tan inverse of root of 1 minus x square. X is now sin theta, so this will be now sin square theta divided by x is sin theta, right? So this is equal to, y is equal to tan inverse of root of 1 minus sin square theta will be cos theta divided by sin theta. So cos by sin will be cot. So this one we can write as tan inverse of cot theta, right? So we need to convert cot into the tan form. So this can be written as tan inverse of, what can be written as tan of pi by 2 minus theta. Is it clear? Can we write this pi by 2 minus theta? Pi by 2 minus theta means theta is in the first quadrant. Here the angle is in the first quadrant. So we can write this as tan of, tan of pi by 2 minus theta. So tan inverse and tan will get cancelled. We got y is equal to pi by 2 minus theta. So this is equal to pi by 2 minus, what is theta? Theta will be sin inverse x. You have to substitute this because we have taken the substitution here. So this is y. Now dy by dx, or we differentiate with respect to x. Dy by dx, pi by 2 will be 0 minus sin inverse x derivative will be 1 by root of 1 minus x square. I hope you understood this one. So we got dy by dx. Now we will consider the second function, that is t is equal to cos inverse of 2x into root of 1 minus x square, right? To give the substitution, we have to give the same substitution because we are differentiating this one with respect to that. So we cannot change this. So this is now cos inverse of 2x is now sin theta, right? And directly here I write 1 minus sin square theta will be cos theta. So this is equal to cos inverse of 2 into sin theta. Cos theta will be, it's a form of sin to theta formula, right? So this is equal to sin to theta. So cos inverse it will be in the first quadrant. Pi by 2 minus 2 theta will be in the first quadrant, but the angle of theta is between pi by 4 to pi by 2. So see, pi by 4 less than theta less than pi by 2. This is the angle theta. So 2 theta will be, we have to multiply by 2. So this will be pi by 2 less than pi, right? So the angle 2 theta is between pi by 2 to pi. So if you consider this one as pi by 2 minus 2 theta, it will be in the first quadrant, but the angle 2 theta should be in the second quadrant. Is it clear? The angle 2 theta will be in the second quadrant. So directly we cannot write this one. We can write this as cos inverse of pi by 2 minus of pi minus 2 theta. Is it clear? Minus of pi minus 2 theta, because it is in the, if I consider pi minus 2 theta, obviously it will be in the second quadrant. So this will be cos inverse of pi by 2 minus pi will be minus pi by 2, minus into minus will be plus 2 theta. Here cos inverse and cos will get cancelled. This is equal to minus pi by 2 plus 2 theta. Clear? So we got the value of t. So this one can be written as minus pi by 2 plus 2 into what is theta? Theta will be, yes, x is equal to sin theta. So theta will be sin inverse x. So if we differentiate this one, this will be 0. So 2 into 1 by root of 1 minus x square. Derivative of t with respect to x will be dt by dx. Is it clear? Actually we have to find dy by dt. So divide these two, dy by dx divided by dt by dx, so that we will get the value of dy by dx. I hope you understood this one. Okay. Directly if you consider here, see here, if you consider pi by 2 minus